Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following trigonometric algebra problem. The first problem says, if sine to the power of 4x divided by sine squared y plus cosine to the power of 4x divided by cosine squared y equals 1, what is the value of sine to the power of 4y divided by sine squared x plus cosine to the power of 4y divided by cosine squared x? And for problem B, if sine to the power of 4x divided by cosine squared y plus cosine to the power of 4x divided by sine squared y equals 1, what is the value of sine to the power of 4y divided by cosine squared x plus cosine to the power of 4y divided by sine squared x? Now these look rather complicated, but the difference between given expressions and want to find expressions is that x and y are switched between numerators and denominators. And the difference between the first problem and the second problem is that the two denominators are switched. That is, sine and cosine are switched. And if you still think that this is complicated, I hereby tell you that the only trigonometry formula that I am going to use in this video is sine square theta plus cosine square theta equals 1. Of course, I will use some other polynomial-related formulas, but the only trigonometry-related formula used in this video is this sine squared plus cosine squared equals 1. Alright, now let's get started. The first problem. We have to manipulate and simplify the given condition, so let's start by multiplying sine squared y cosine squared y on both sides. This gives sine to the power of 4x cosine squared y plus cosine to the power of 4x sine squared y equals sine squared y cosine squared y. And perhaps this is the part where many people get confused about how to apply the trigonometric formula. There can be more than one way to do it, but what I want to do here is to change this sine to the power of 4x using sine squared x equals 1 minus cosine squared x. Then we have 1 minus cosine squared x squared, because the power of 4, cosine squared y plus cosine to the power of 4x sine squared y. And let's write it as minus sine squared y cosine squared y equals 0. One good thing about this manipulation is that now we have only cosine function for variable x. You may want to do the similar thing for variable y, but let's actually expand this squared part first. Then we have 1 minus 2 cosine squared x plus cosine to the power of 4x cosine squared y plus cosine to the power of 4x sine squared y minus sine squared y cosine squared y equals 0. So by distributing this cosine squared y, we have cosine squared y minus 2 cosine squared x cosine squared y plus cosine to the power of 4x cosine squared y, and the remaining terms plus cosine to the power of 4x sine squared y minus sine squared y cosine squared y equals 0. Notice that this and this can be grouped as cosine squared y times 1 minus sine squared y. Then we have minus 2 cosine squared x cosine squared y. And this can be written as cosine to the power of 4x times cosine squared y plus sine squared y. And this equals 0. Here, 1 minus sine squared y equals cosine squared y, and cosine squared y plus sine squared y equals 1. So we have cosine to the power of 4y here, minus 2 cosine squared x cosine squared y, plus cosine to the power of 4x equals 0. And you can easily notice that this is in fact cosine squared x minus cosine squared y squared. So we have cosine squared x minus cosine squared y equals 0. So we have cosine squared x equals cosine squared y. And we also have sine squared x, which is 1 minus cosine squared x. But since cosine squared x equals cosine squared y, we have 1 minus cosine squared y, which is sine squared y. So we have sine squared x equals sine squared y. But here you cannot derive this like this. Alright, so cosine squared x equals cosine squared y. Alright, then cosine x equals cosine y, which means that x equals y. So sine squared x must be equal to sine squared y. This is wrong because cosine squared x equals cosine squared y does not automatically guarantee cosine x equals cosine y. It is actually either cosine x equals cosine y or cosine x equals minus cosine y. And even if we have some other problems where cosine x indeed equals cosine y, this does not automatically guarantee x equals y, which is pretty obvious from the periodic/symmetric nature of the cosine function. So be careful not to make these mistakes. And back to the problem. We want to find the value of this expression. And using these two results that we have obtained, sine squared x in the denominator equals sine squared y, and cosine squared x equals cosine squared y. So we have sine squared y plus cosine squared y, which is 1. And now the second problem, where this is now cosine squared y and this is sine squared y. But the process is pretty much the same. Multiplying sine squared y cosine squared y, we have sine to the power of 4x sine squared y plus cosine to the power of 4x cosine squared y equals sine squared y cosine squared y. And again, we change this sine to the power of 4x into 1 minus cosine squared x squared. So this times sine squared y plus cosine to the power of 4x cosine squared y minus sine squared y cosine squared y equals 0. Then we expand this part. So 1 minus 2 cosine squared x plus cosine to the power of 4x sine squared y plus cosine to the power of 4x cosine squared y minus sine squared y cosine squared y equals 0. Here, notice this sine squared y and minus sine squared y cosine squared y. So we have sine squared y times 1 minus cosine squared y. And then this minus 2 cosine squared x sine squared y. And then cosine to the power of 4x is in here and here. So cosine to the power of 4x sine squared y plus cosine squared y. So this 1 minus cosine squared y equals sine squared y, and sine squared y plus cosine squared y equals 1. So we have sine to the power of 4y minus 2 cosine squared x sine squared y plus cosine to the power of 4x equals 0. And the left hand side is the perfect square again. This time sine squared y minus cosine squared x squared. So sine squared y minus cosine squared x equals 0. So cosine squared x equals sine squared y. Also, sine squared x equals 1 minus cosine squared x. And using this equals 1 minus sine squared y, which is cosine squared y. We want to find the value of this expression, now with x in the denominators and y in the numerators. And using the conditions that we have obtained, we can change the denominators into sine squared y and cosine squared y. So we have sine squared y plus cosine squared y, which is 1. And that's all for today's video. Thank you for watching, and I will see you in another video.